Hello everyone. For this video, we're going to talk about annuity. So, what do we mean by annuity? It is a series of payments, cash payments that are paid or received over time at regular intervals. So, annuities can have equal or different amount payments, but they must occur regularly. Example, if you're plan to buy a car or a condominium or a house, you have to pay this product over time on a regular basis. And we have two types of annuity, the simple and general annuity. So the difference is that for simple annuity, the payment interval and interest period is the same. Whereas for general annuity, the payment interval and interest period is not the same or different. So for example, you want to buy a house or a condominium and you want to pay it every month. So you'll give a monthly payment. And the interest period would be, let's say, 5% monthly. There. So the payment interval is every month. And the interest is also monthly. So that's simple annuity. Okay. For general annuity, let's say you have an insurance, you bought an insurance and you're going to pay monthly. So again, it's a monthly payment of X amount. But the interest period, it's compounded, let's say semi-annually. Let's say 5% semi annually. There. Okay. So the payment interval is monthly, but the interest period is twice a year or semi-annually. Okay, so that's the difference. So let's solve some problems. And before we do that, let's write down the formulas that we're going to use. So we have future value and present value formula. So for future value, it's equal to R times 1 plus j raised to the nth power minus 1 all over j. Whereas present value PV, it's equal to R times 1 minus quantity 1 plus j raised to negative n over j, where R is the regular payment and j is equal to I equals M, or this is the interest rate, and M is the number of conversion period. So if it's annually, M is equal to 1. If it's semi-annually, M is equal to 2. For quarterly, it's equal to 4. And for monthly, it's equal to 12. And our N is the number of payments. Now, this formulas varies because different books use different variables, but they're all the same. Okay, for general annuity, we will do that with our next video. So for now, we're just going to concentrate with simple annuity problems. So let's start with our problem number 1. How much money will you have after 6 months if you want to save $3,000 every month in a fund that gives 9% compounded monthly. So in this case, this problem is a simple annuity because the interest rate is monthly. Oops. And the regular payment or savings will also be monthly. Okay, so let's identify our given. So the regular payment is $3,000. The interest is 9%. So change to decimal, that's 0.09. Our M, because it's compounded monthly, so that's 12. Therefore, to get our letter J, that's I over M. So 0.09 divided by 12, that's equal to 0.0075. All right, and our N is equal to 6 months. So 6 months, so that's half a year for over 12 months. Okay, so that's equal to 6. So the N, it should always be in years. All right, so let's plug this into our formula. How much money will you have after 6 months? So we need the future value. So the formula is R times 1 plus J raised to N minus 1 over J. So R is 3,000 times 1 plus 0.0075 raised to 6 minus 1 over J, 0.0075. So let's get our calculator. So the future value is 18,340.89 dollars. Okay, next. Number 2, if you decide to save $200 at the end of each month in a bank that pays 0.25% compounded, it should be compounded monthly, how much will your money be after 6 years? So after 6 years, so again, they're asking for the future value. And this is again a simple annuity because the interest rate is compounded monthly and you're saving 200 each month. So month, it's the same. So let's identify the given. The regular payment R is $200. I is 0.25%. In decimal, this is equal to 0.0025. N is 6 years, and there's 12 months in 6 years. So it's 6 times 12 is 72. And M is, of course, compounded monthly. So that's 12. So for RJ, 0.0025, I divided by M is 12. So this is 0.000208333, or just that. Okay, so future value is equal to R times 1 plus J raised to N minus 1 over J, and substitute the values that we have. So that's 200. 1 plus J is 0.0002083 raised to 72 minus 1 over J. Okay, let's use our scientific calculator, and we'll get an answer of $14,507. Okay, next. Number 3, how much money do you need to invest to be able to have an annual cash flow of $1,000 for the next 5 years if the annual interest rate is at 6%? So they're asking for the money that you need to invest. So that means we're looking for the present value. Okay? And to have an annual cash flow of 1,000 if the annual interest rate is at 6%. So again, this is the same. So this is simple annuity. So the formula for that is present value is equal to R times 1 minus 1 plus J raised to negative N over J. Okay. So we have R, the regular payment of $1,000, times 1 minus 1 plus, what's our word J? J is equal to I over M. The interest rate is 6%. So 6% is 0.06 over M, annual interest rate. So it's annually over 1. So it's just 0.06 raised to N. The N is annual cash flow for 5 years. So 1 times 5 is 5. So it's raised to negative 5 over 0.06. Okay, with the help of our calculator, the present value would be 4,212.36 dollars. Okay, we'll have more example with our next video. See you. Thank you.